Hi, and welcome to question 3 of the 2024 paper 1 for the Leaving Cert Ordinary Level Maths. So question 3 starts off with, could be tax, we'll get stuck in kind of algebra, whatever. A toy shop sells two different sets of the same building blocks, sets A and B, as shown in the diagram below. So set A, 60 blocks cost €12. In set B, 150 blocks cost 28. Which set of building blocks works out cheaper per block? Use calculations to support your answer. So with A, we have 60 blocks equals €12. And for B, we have 150 blocks is equal to €28. So if I know how much one block costs for A and B, well, then I can just tell which is cheaper. So the way to convert the 60 blocks here into one block would be to divide the 60 by itself. That will get rid of it. And I'm algebraically correct as long as I do the same thing to the other side. So the 60 divided by the 60 cancel to give 1. On the far side, 12 over 60 is 1/5. So one block is equal to 0.2 of a euro. You could use the calculator there. I should check it myself. Now, the far side would be, well, if 150 blocks is equal to 28, we can get rid of that 150 by dividing by itself. If we do it one side, we can do it to the other, and we find one block is equal to, now let's use a calculator, 28 divided by 150. I got an answer of 0.186 euro. So which is cheaper? Well, B is. Okay. Why? Well, 0.18 is less than 0.2. B is cheaper. Now, bad writing aside, that's pretty organized. So in the notes, I did the same thing. I have my initial statement. I simplified it to find out what 1 is. I did the exact same thing on the far side, and then actually never gave a reason. I must go back and fix that. I should be explicit and state it, although arguably this is the statement. Yeah, but I should have explicitly stated it. I even wrote in the wrong. Anyway, I messed up doing the notes. It should be set B is marked. Okay, so then onwards to part B. Part B says solve the following equation in x is an element of R. So don't worry about this. This just means x can be any number. So we have 3x squared minus 5x plus 1 is equal to 0. Now this is a quadratic. Okay, I know that because it has all the one variable. The biggest power is 2. Okay, it will have a predictable shape. It will follow the quadratic patterns. So give each answer correct to 2 decimal places. Now, the fact that they're asking for decimal means that factorization won't work. It's most likely going to have to be the minus b formula. So let's get stuck in. I'm going to compare this to the general form of a quadratic. And that tells me that a is 3, the number in front of the x squared. B is minus 5. And C is 1. So that formula there, the quadratic formula, is given to you in the math tables with the quadratic formula, okay, which is this. So if I know the A, B, and C values, I can just substitute them in. Now I'm going to put any negative numbers in brackets. Okay, 3. Here's where my bad writing will make me fall down. 2 times 3. So bad writing aside, that can be programmed into the calculator. I can put it in with the plus and then get my answer and put it in with the minus. Now I have it done out on the next page here. So again, there's the formula. That's the general form. That's the quadratic we're dealing with. My values of A, B, and C identified from the quadratic. Okay. Then I substitute them into the formula. Okay. The A, B, and C. Put them through the calculator with the plus. I got 1.434, but they are looking for the answer to 2 decimal places. 4 is less than 5, so the number before stays the same. The other one with the minus, I put it through, I got 0.232. Again, the third decimal place is what matters. When we're rounding to 2 decimal places, that is less than 5, so the number before it stays the same. And I got 1.43 and 0.23. And that's it. Okay, and that's where that particular graph crosses the x-axis, okay, which has value. Now, the next part then is on simultaneous equations. So part C here is obviously algebra. It's simultaneous equations, but they tell us that. So it says here, use algebra to solve the simultaneous equations 2x plus y is equal to 5, which would be linear. Okay, now I'm trying to look it out in my head. It'll be minus 2x. It'll be crossing somewhere up here around 5 and going down. Okay, that's what it should look like. Now, I've done that by rearranging that into the form y is equal to mx plus c, and I can see that the minus 2 represents the slope, and the c is where it crosses the y-axis. Now, the second one, x squared plus y squared is equal to 25. That's a circle, okay, with radius 5. Okay, so I'll do something like that. So we're looking for where does the line intersect the circle. So I'm thinking there's 2 spots based on that preliminary pilot diagram. So it says, no, it gives a hint. First use 2x plus y equals 5 to write y in terms of x. Okay, so what they're saying there is take my easier equation, and to my mind the 2x plus y is equal to 5 is easier looking, and rearrange it for one of the variables. Now, the easiest one there is for y, but they tell you that, okay? Well, if we were rearranging this, we do it for the one that is on its own. So I'd get rid of the minus 2x by taking 2x away from it. If I do it to one side, I have to do it to both sides. They'll cancel out. You're left with y is equal to, I can go minus 2x plus 5 or 5 minus 2x, whichever way you want. Now, I can use this simpler equation in my other equation. It's supposed to be a y. So I know that in either of the equations, 1 or 2, there are 2 unknowns. I can't solve an equation of 2 unknowns. But if I can compare 2 different equations of the same 2 unknowns, we can use this trick, and it can be either the substitution method or the elimination method. Okay. Now this one here is the substitution method. So I'm going to substitute my rearranged simpler equation instead of my variable in the more complicated equation. And when I do that, I'm going to end up with this statement. Okay. If you notice here, are there more than one variable? Like there's an x and an x, but it's the same x. So this is an equation of one unknown, and that's solvable. Okay. So let's go ahead and do it. Now this 5 minus 2x squared is going to create a problem. Okay, that's the same thing as 5 minus 2x multiplied by itself. Now the standard method here is to write one of the brackets out twice. Okay, I normally suggest writing the second bracket out twice. Then the first term of the first bracket in here, the second term of the first bracket in here, that was a minus 2x, and then go left to right. 5 times 5 is 25. 5 times minus 2x is minus 10x. Keep going left to right. Minus 2x by 5 is minus 10x. Minus 2x by minus 2x is plus. Minus by minus is plus. 2 2's is 4. X by x is x squared. Now we end up there with a statement 25 minus 10x is minus 20x plus 4x squared. Now I did all that to manipulate this little part of the expression. So I'm going to swap it back in. Minus. Just got to be careful I don't forget to keep the 25 and keep the x squared. Okay. Now I'm going to combine them all together. So what can be added here together is the x squareds. I'm going to write in order 4x squared minus 20x plus 25 is equal to 25. Now, I want all the numbers on one side, so I'm going to take 25 from the right. If I do that on the right, I have to do it to everything on the left. And I'm left with 4x squared minus 20x is equal to, they cancel and they cancel, is equal to nothing. Now, at this stage, I've run out of space. But we can factorize this using the minus b formula. The a value would be 1, or sorry, a value would be 4, the b value would be minus 20, and the c value would be 0. Or you could use factorization. Now I should have that on further in the notes. Okay, actually I'll just take it over from here. So 5x squared minus 20x is equal to 0. Now I could pull out something from these two terms. Okay. Now if you see it, x is there in both terms, but also 5x. So if I divided 5x squared by 5x, I'd be left with x. So when you pull out 5x from 5x squared, it's the same thing as dividing by it. Okay, and what are you left with? Well, the 5 and the 5 cancel, the x cancels one of the x's, you're left with x. So when I pull 5x out of 5x squared, I'm left with x. That's kind of what we mean when we say that. Now I want to pull 5x out of minus 20, so minus 20x divided by 5 would be minus 4x. Okay, actually divided by 5x. So divided by 5x. So the x will cancel. 5 into minus 20 goes minus 4 times. And that's where I get this. So you have two factors here. It's either 5x is equal to 0, okay, which means x is equal to 0, or it could be x minus 4 is equal to 0, okay. And if you're getting rid of the 4 here, I'm going to add 4 to both sides. That'll cancel the 4's here, and I got an answer of x is equal to 4. So I have two x values, either x is equal to 0 or x is equal to 4. Now at this stage, you're not finished yet, okay, I'm going to have to move to another page. We can now use that x value in the original equation, okay, the simplified one, and this is the one we got with y is equal to 5x minus 2. So we know that x is equal to 0 or x is equal to 4. When x is equal to 0, I substitute it in, okay, instead of the x. 5 minus 2 times 0 is 5. So one variable is 3 on the x, 0 on the x, 5 on the y. The other, where x is equal to 4, I substitute 4 in instead of x. Okay, put it to the calculator, I got minus 3. So for that other point, when x is 4, y is minus 3. That's the answer. Okay, now ultimately at the core of all this, we had a line, okay, and a circle. And this particular method is designed to find where does the line cross the circle. Now, in the old days, they might ask you this in regards to circles, and they might say, prove the line L is a tangent to the circle C. And if it touched at 1 point only, it was a tangent. If it touched at 2 points, it was a chord. Okay, but again, that's not the way the question is generally asked anymore. But at the back of this, there is a practical thing that is or can be used. Okay, so in essence, if we go back over it really quickly, and if you're good to go, just move on. So when we started this question, we took our easy equation, we rearranged it for the simplest variable, which they told us to do. They told us was y, and we got a rearranged version of that. Then in the other equation, we substituted that y term instead of them. Okay, now that created all this kerfuffle with having to expand this out, and I just kept it going within the question here and let it work within it, and everything else just carried over every single time. Eventually I got to a point where I could simplify down, and I did, okay, and I got to a point where I had a quadratic that needed to be factorized. I could have used the minus b formula, the quadratic formula, or just one of the factorization methods. I went with one of the factorization methods, found my two values of x, then used them in my original equation to find the two corresponding values of y. And that was it. So fairly bog standard thing in the Leaving Cert, usually worth quite a chunk of marks, can come up multiple times. There's two different methods. There's the elimination method, okay, and then there's the substitution method, which is what we've just done. And that's it. Okay, so I think that's the end of question 3. So as always, if you want to copy the notes I'm working off, send me an email at shanetroy@gmail.com. Like and subscribe to get access to more playlists, and see you on question 4.